Hi class, and welcome to the third video lesson on our first section of chapter 7 here, 7.1. In this one, we're going to be basically hitting the highlights of some of the most important parts of polynomial functions. What I kind of compare this to is me being a sports lover that I am, I kind of compare this part of the lesson to Sports Center. Instead of watching a 3-hour-long football game, what some people might just do is they just might watch Sports Center just to get the highlights of that game, get the touchdowns, get the interceptions. They basically just get the most important parts. Or it might be like remembering a movie. Oh, have I seen that movie again? How does it go again? And then someone might explain how the beginning starts, or might explain maybe some of the most exciting parts of the movie. Once you get that, yes, there, now I've seen that movie, or oh, actually I've never seen that movie before, I'm going to have to watch that one. It's kind of the most important parts. And so here's what they are. There are 3 main points that we're going to stress on in this video lesson. For evaluating these polynomial functions to see what they look like, if both arrows go up or down, we know that the degree is even. So it could be x to the 4th, x to the 6th, x to the 8th, x to the 2nd. As long as that highest exponent is even, we know that both arrows are going to go up or both arrows are going to go down when we look at their graphs. If they go in opposite directions, their degree is odd. So if it's x to the 1st or x to the 3rd to the 5th to the 7th, I know that they're going to go in opposite directions. If one starts down, the other end is going to start up, or if one starts up, the other direction is going to be going down. And then the other third bullet point is to find the number of real zeros. All you have to do is look at the x-axis and count how many times it crosses the x-axis. That's going to be the number of real zeros that it has. So for an example, here's the one on the left. This one isn't on your notes, so just sit back and relax. Watch me. This one is our parabolic function or our quadratics. We studied these in chapter 6. We know that they have 2 real zeros. It crosses the x-axis twice. So that's how we know it has 2 real zeros. For our quadratic functions, an example would be like y equals x squared plus 3x minus 4, something like that. What's our degree? Our highest power of x is x squared. When it's even, it means that both arrows go up or both arrows go down. As you can see, both of our arrows here are going up. They're going in the same direction. When they go in the same direction, we know that this is even. Okay? I believe that's all it required of us. If we look at this next one, how many real zeros are there? It crosses the x-axis here, here, and here. So this has 3 real zeros. If we look at this one, is it odd or is it even? This one is going down to negative infinity, and it's ending up going up to positive infinity. When this is the case, when they go in opposite directions, this degree is odd. It's most likely going to be a cubic function. We don't know for certain, but we do know certainly that the degree is odd. So that's all we're doing here in this video lesson, class. We're just getting the highlights. We don't need to watch the entire game. We don't need to know what is happening at each and individual one of these points. All we want is the highlights. So let's practice doing that. The first and the third parts, this part and this part, are hopefully the most simple ones. The one in the middle does take a little bit more energy and effort, but hopefully nothing too difficult. First of all, is the degree even or odd? The arrows are going in the same direction. They're both going down. When this is the case, it is an even function. Next one, we're going on to the third. Let's do the first and the third. Let's get the easy ones out of the way. How many real zeros are there? Here's our x-axis. How many times does it cross the x-axis? It crosses it twice. So there are 2 real zeros. Now, defining the end behavior. The end behavior is basically what happens at the very, very beginning and what happens at the very, very end. So here's how we're going to do that in this class. Now watch me very carefully the first time so that you won't get confused in future times. What we're going to do is we're going to describe what happens to the graph as we move to the left and what happens to the graph as we move to the right. So the notation that we're going to use for that is we are going to write these words. As x approaches negative infinity, and as x approaches positive infinity. For all four of these, you're going to start off both of them just like this. So as x approaches negative infinity. So our x-axis is this one right here. What happens, class, as we go to the left? What happens to our y value? As we go left, our y's go down and down and down and down, correct? They go all the way down to negative infinity. So what you're going to put is as our function moves leftward, as x approaches negative infinity, our y, which is another way of saying that, is our f of x. That's going to be mathematically correct. This is how I want you to write it. F of x also approaches negative infinity. As x approaches the left, our f of x approaches negative infinity in going down. Okay? Now let's see what happens as we go to the right. As x approaches positive infinity, so as I move to the right, what happens to my y's, or what happens to my f of x? It goes down and down and down and down, which means it also approaches negative infinity. So my f of x also approaches negative infinity. So as I move to the left, I go to negative infinity, and as I move to the right, I go to negative infinity. Hopefully this makes sense. If it doesn't the first time, hopefully after we do it 3 more times, it will all make perfect sense. Next one. Letter B. Is this degree even or is it odd? They're going in opposite directions, class. So when they go in opposite directions, that means that our function is odd. The third one, how many real zeros are there? Well, how many times is it across the x-axis? 1, 2, and 3. There are 3 real zeros. All right, the tricky part. You're going to tell me what happens as I move to the left and what happens as I move to the right. So we're always going to start off like this. As x approaches negative infinity and as x approaches positive infinity. You tell me what happens. So as x approaches negative infinity to the left, what happens to my y value, or what happens to my f of x? My f of x approaches, notice how it's getting lower and lower and lower and lower. That means it's approaching negative infinity. Now you're going to tell me what happens as x goes to the right, or as x goes to positive infinity. What happens to my y values as I go to the right? I go up and up and up and up. So as x approaches positive infinity, my y's, or my f of x, also approaches positive infinity. Hopefully this one is easier than the first one. Let's move on to number 3, or letter C. Is this degree even or odd? Notice how they are ending up in opposite directions. It starts top left, it ends bottom right. So the opposite directions, it means that it's an odd degree. How many times does this cross the x-axis? Just once. So there is 1 real zero. Now you're going to tell me what happens as x approaches negative infinity, or as it moves to the left, and what happens as x approaches positive infinity, as it moves to the right. So as we go leftward, my y values get higher. They go up and up and up and up. So it goes to positive infinity. So as x approaches negative infinity, my f of x approaches positive infinity. Let's see what happens as we move to the right. As we go right, our y values get lower and lower and lower and lower. They're descending, which means it's moving to negative infinity. So as x approaches positive infinity to the right, my f of x approaches negative infinity as it goes down. All right, after A, B, and C, hopefully letter D, you're experts now. Pause the video. You guys try this one on your own. All right, here's what you should have gotten. Is the degree even or odd? the arrows end in the same direction. When it's the same direction, it means it's an even function. Here is my x-axis. It doesn't cross my x-axis at all. So how many real zeros are there? There are none. Now there are zeros, class, okay? There just aren't any real zeros. We'll talk about that further in depth as we go on. But there are no real zeros, so you can put none. And then we're going to put what happens as x approaches positive infinity, and what happens as x, sorry, let's do negative infinity first, as x approaches negative infinity, and what happens as x approaches positive infinity. So as x goes to the left, my y values go up. So as x approaches negative infinity, f of x approaches positive infinity. And then as we move to the right, as x approaches positive infinity, my y values approach positive infinity. F of x also approaches positive infinity. I hope each and every one of those got easier for you as we went. If you have any questions for me, especially on that end behavior, I would be more than willing to help you out a little bit better. It might help to use some, physical examples with arm gestures and so on and so forth. So let me know if you need any other help, if you have any questions on that and need some additional help with that. One thing I want to leave you with before I give you your assignment in class tomorrow is what happens when you see something that looks like this. This is a typical Excel math type question. You might see this, where you have a restriction where it says x cannot equal a. All you're going to do here, class, is you're just going to evaluate. So here we have f of x equals 3x minus 3. So find f of x minus f of a divided by x minus a. Here's f of x. So f of x is 3x minus 3. So let's put 3x minus 3. That takes care of this part. Now you're subtracting f of a. So if I were to have an f of a, if I were to put an a right here, I'd also have to put an a right here. So we're subtracting 3a minus 3. Instead of f of x, this is now f of a. So I'm just going to put an a in for x. So I get 3a minus 3. That divided by x minus a. I don't have to substitute in anything in the denominator because there's no f in front of it. This is the f of x part. This is just two letters x minus a. So now I'm going to evaluate this. The first thing I'm going to do is I'm going to distribute this negative sign to get rid of my parentheses. So now in the numerator, I have 3x minus 3 minus 3a. A negative 1 times a negative 3 is a positive 3. Divided by x minus a. Continuing to work. Combine like terms in the numerator. A negative 3 plus 3 is 0. So those are now gone. So in the numerator I have 3x minus 3a. In the denominator I have x minus a. Now we're going to pull out something that we use a lot in chapter 5, and that's going to be, let's take out the GCF. So this becomes, both of these have a 3 term, so I can take out that 3, and I'm left with x in the first term and a negative a in the second term, divided by x minus a. Now we're going to practice this a lot more when it comes to chapter 9, but we'll just give you a little taste about what you're going to be seeing in chapter 9. Anything divided by itself is 1. 7 divided by 7 is 1. 12 divided by 12 is 1. X minus a divided by x minus a is just 1. So it cancels out. So all we get is the number 3. So for Excel math, whenever you get something that really looks like a very difficult problem to solve on this particular objective, oftentimes it comes out nice and clean like the number 3. So be prepared for that when you see objective 86. You're also going to have a few problems on evaluating polynomial functions, telling me the ending behavior, so on and so forth, for a few problems 16 through 44 evens. You'll get that in class tomorrow.